The only reason I'm here as a mathematician is because someone finally came up to me and said, hey, try this without numbers. And I was able to overcome my personal problems and anxiety with math, which was severe. And become the most senior level faculty member at my college. I'm the full professor rank. I got 20 years of teaching experience just about at the university level. I was headhunted to teach algebra. I mean, this is for someone who can't do math at the grade school level. That's kind of surprising. And remember, I'm just going to go back to that previous example. This is what we had on the board, which up to this point is just fine. And yeah, it would make a great example because the only way we can factor a fourth degree polynomial is in general is to guess a root using the factors of 6 and then some damn good guessing, which I know one guy who can do this. I don't even know how he does it. Every time he tells me I forget. But that's about it. Right? You got to be a good guesser. Right? Or this. Same idea. And it is, so when we talk about analogous tasks, this is the analogous task. There is a task in algebra which could be perfectly mimicked by a change in instruction to adding fractions. And that change is extremely subtle. It might be so subtle that we may think we're doing it, but we're not because of our notational differences. So let's talk about this again before we go on. How long have I been doing this already? 20 minutes? Okay. So the algebraic properties can be used in arithmetic instruction. So even separate from even separate from algebra, we can introduce some very prevalent algebraic properties without our students even knowing it. But on the flip side, we have to be careful. If we teach them to multiply across, we can have that negative effect where they can become experts in adding and simplifying fractions and not ever be able to make the jump into algebra because the process of simplification is in a different order. And that could, with no fault to you or no fault to the educational system, if this isn't caught or we're not aware of it, we're actually prohibiting people from being able to make analogous tasks later because we hid those properties inside of a standard algorithm or an easy to remember phrase. Like, oh, you don't need common denominators to multiply, you just multiply across. Is it a true statement? Yes. Is it a major barrier to algebraic thinking? And I think it could be, because we're removing the properties and the interactions between the numerator and the denominator, and we're replacing them with computation. So anytime we have a computation of any kind, we remove that potential connection to something algebraic. Calculators can be a very good thing. However, if we're trying to teach algebra, I would argue that they're one of the major roadblocks to getting people to look for and think of ways to avoid doing calculation. Why am I good at what I can do? Why am I good at what I do? Why was I so good at calculus? Because I was so terrified of making calculations with numbers, I would push those letters around for days until I found an analogous task that would then remove all the work from me in the future. We can reduce math anxiety because these factoring techniques, by their nature, always make things smaller, right? You think of 15, think of its factors. You think of 315, and think of its factors. Oddly enough, I cannot multiply things together to get 315. I am not joking, but I can look at 315, instantly pull out a 5, instantly pull out the next number, and it's a skill that can be developed. It's a skill that can actually be developed at a fairly young age, even in the middle schools. We can build on the ideas that mathematics is not about numbers. It's about pattern recognition and connections between the operations. We all know that multiplication, division, and factoring are the same, but our students really don't believe that. And proof is the ones that are in my classrooms. they honestly believe they are different. That they can be good at multiplication and not division. Those kinds of facts. And to me, it's like, whatever. It just doesn't make sense. And then we can show a beauty of algebra to hopefully motivate them to want to see those big letter problems. Even in basic computation that I never saw, and none of the students in my class remember. So even if we are teaching this, it's second to the other algorithms, to where they're not remembering these techniques. Now, look how subtle these differences are, right? I mean, we could argue that the exact same thought process has to be there, right, in order to find a common denominator. How about adding fractions? Adding fractions taught with least common multiples, at least in every textbook I could find, least common multiples can be constructed with multiplication or with factors. It's in both. Where do we put the emphasis? What do we allow to happen? I mean, I see the factors of 12 here, 6 and 2. And we're getting the same answer over here that we are over here, but the way in which we write it. Notice that everything on the left has larger numbers, everything on the right has smaller numbers. And this is a problem which doesn't even need to be simplified.
So what do you do when you have a mixed number then? Do you separate the whole numbers together and the fractions together?
My experience with algebra and calculus and above is that real math abhors mixed numbers. That mixed numbers are called proper because of the queen. Right? Proper fractions versus improper fractions. Why is it proper? Because I don't go to the store and order 5/3 of a pound of meat. That's the only thing improper about it. As far as the math is concerned, I think that the mixed number is the most improper, inappropriate thing I have ever seen mathematically. And it should and is never used. And watch it, Lisa, when was the last time you used a mixed number? Outside of the grocery store.
I cannot remember.
They don't. They do not exist in mathematics. It's spoken English. And yes, we do need to teach our students, that the way we speak in this country, it follows certain grammatical rules so that I don't say 5/3. What do I say? 1 2/3? I'd say 1 2/3 of a pound of meat.
Or if you're making biscuits and you use 1.5 cups of flour or something.
I mean, there's definitely applications for it, but they're not college level applications. And yes, I'm taking a very narrow focus, but I mean, be honest with yourself. Why would we teach someone algebra if they're really not? And I don't know the answer to this, but if they're really not got college ready goals, is there really a value to algebra? I mean, my grandmother doesn't know it. She's pretty successful. She can do mixed numbers in and outside of her head like you wouldn't believe. So for society, yes, we have to be teaching mixed numbers. But we should not expect that mixed numbers will help our students make a transition to algebra. Right? Unless we started writing them, say with like correct math notation. Right? Because 2 1/4 is 2 plus 1/4. And so if we're going to multiply 2 1/4 by 3 1/2, it shouldn't be surprising that we should have to distribute. I mean, I think that there are things with mixed numbers we can use to show why they don't work algebraically and use them to help with an algebraic property. But no. I'm not going to talk about mixed numbers. But only because of, our goal is to get to algebra. If our goal was to do something else, I would talk about mixed numbers. And in fact, I lied a little bit. Gallatin College from the start did have a very small workforce component, and I had to teach math for welding students, which of course was very high on mixed numbers and big on decimal calculations so that they could dial it into the machine. And it took me 3 months to go back and write 3 times 2. Right? I could not do this. You even know what I'm talking about? I mean, once you get to algebra, that's an x, and that's 6x. I mean, I don't care how you write it, I don't care what typewriter you use, I see that as an algebraist at the university, that's 6x, and I don't know why you didn't simplify it. It's not 6, it's 6x, because once you get to a certain level, that's not multiplication anymore. And so I had to go back and retrain myself to be able to even write this. And my students kept asking me, why do you keep writing 3.2? Because as welders, to them, the only reason the dot ever existed was it was on their paycheck or on a bill, right? That was a decimal, and that was all it ever was. So yeah, we have to be aware of our audience, and as middle schoolers, your audience is different from mine, right? I mean, there's no doubt about that. And even high school, we've got to do both. But if we're trying to go to algebra, I mean, it's no surprising that to an algebraist, that's not multiplication. I mean, that shouldn't be surprising. But to this day, I can't read it outside of the context of my room without thinking of what that is. So this has been up there for a while. We've stared at it. Can you use a factor-only technique to do this? Or is the other technique so ingrained in our head that it's automatic, that 14 pops into our head like we're the smart guy? I mean, that's my question. So what do we think? You guys think something. What do you think? You think it looks funny, right? Because the old method is so ingrained in our head and in our students' head, right? I mean, it does look funny. It looks funny because it's not what we're used to in any sense. It's not used to what we do notationally. It's not used to the way we describe finding common denominators, right? If you're finding a common denominator, the goal should be for someone to say 14, not for someone to say 2.7. I mean, that's why it feels funny, right? Because we know that we got to find that 14. All right, so try this one. And I'm sorry if I'm teaching, if I'm assuming something here. I don't have a damn clue what this denominator is, and I don't think I could find it through multiples. So that's why I picked it. But I'm guessing some of you can, and then I don't have a good enough example. I don't know. I'm not supposed to write on that board. But what do you know about 14? Just so that we don't, so if we haven't used this technique, we might not be comfortable with it. So let's just take a break with where we are and tell me, what do we know about 14? It's 2 times 7. Are we comfortable with that part?
Yeah.
All right. And what do we know about 50? It's 2 times 5 times 5. So did we get this far with the original question? Okay, so what's missing over here that that's got? That's what makes it common. What's missing over here that this has got? What did I erase? Hey, is there a 5 over here? We need 2 5s. So what we're going to put over here are 2 5s. Okay? And what's over here? What's missing over here?
7.
A 7. And this might take some practice, but your students can do this. They can, if nothing else, they can play the game. Stand out of the camera for the, what's missing? Just make a game out of it. What's missing? What does the left not have that the right has? So that they're the same. Now, here's the big question. What's the common denominator? Ah, see, we fell into the trap again. right? Our brain is so tied to that this has to be a number. We're not comfortable saying something mathematical. What's the least common denominator? 2 times 7 times 5 times 5, or 2 times 5 times 5 times 7, or 7 times 2 times 5, doesn't matter. But for sure not the number, because that's not what made it common. That's not the point. So now we can say, hey, this is 5 times 5 is 25 plus 7. Order of operations, do multiplication, and then add over 2 times 5 times 5 times 7. 25 plus 7, you got to help me out here. 32? Are we in agreement on that? So we have 32 over 2 times 5 times 5 times 7. And then 2 goes into 32. I don't even have to think about what might cancel, whether it might reduce or not. 2 goes into 32 and leaves what? 16. Now, I can still try and divide by stuff, but is anything going to, does it divide by 5? Does it divide by 7? And don't our students know divisibility rules for 5 and 2? And if that list of factors is there, who cares if the top divides by 3? It's a waste of time. Who cares if the top divides by 2? It's a waste of time. And this is how I approach mathematics. I've got to be the laziest person I know. I don't want to do nothing that I don't have to do. I don't clean. You can ask my wife. I don't comb my hair. There's all sorts of stuff I don't do. And one of them is to divide unnecessarily. Or multiply unnecessarily. Now here I'm stuck because I got to do 5 times 5 is 25. And if it wasn't a quarter, I'd have no idea how much that is. But I think it's 175, right? So I get lucky. And if I don't get lucky, I reach for a calculator or a big piece of paper and scratch it out. But do you see how we added fractions by avoiding computation? Because we dealt with it algebraically. Remember, don't ever write 350. Because where on the board would the 350 be? Is it in the final answer? So it doesn't help us. And where did I get the 350 from? You figured it out yet? I typed it into a calculator. 2 times 7 times 5 times 5.
So for some students, did we just skip, obviously, would they think we're just skipping a step because we just knew that 32 was had a factor of 2, and so we took the 2 out of the denominator? Because I'm just thinking, like, if I were explaining this to my 7th and 8th graders, they'd be like, this is, how do you go from there to 16 over?
Okay, so yeah, I did skip a
factoring
step.
the numerator too.
Yeah, but remember, we don't want to blindly factor. I think there's more you can teach your students than I've got today. Today, I really only focus this presentation on don't write the 350.
Okay.
But you have got a great question, right? What do you do to the top? Well, you see, is the top divisible by 2? And the answer is yes. So it's 2 times what? 16. Now, I got 2 choices here. If I want to be very efficient, I would say, is 16 divisible by 5? No. Is 16 divisible by 7? No. So I write a 16 here, I cross those off, and that's what tells me to multiply. I have checked each and every one of my denominators. But I don't just try stuff at random. I don't try and see if the top and the bottom both divide by 3. Right? Which is a huge, how many students divide top and bottom by 3 on their calculator because there's 3's in the problem? You know the answer to that, don't you? It's too many. Because what do 3's have to do? Would the 3 ever cancel out if this was our common denominator? Now I can send you all sorts of worksheets on this where they do cancel and they don't cancel, and we can write it up 10 different ways. My main point is we shouldn't be having them multiply if the problem is about adding. Now the hard sell is we shouldn't have them multiply if the problem was about multiplying. That was the previous problem. That's a harder sell, right? And my instructions when I teach this, they don't change. I don't tell them to factor and simplify. I tell them to multiply. And then I see if they do or not. And the first thing I say is, why'd you multiply? Yes, I set them up, but remember, that's a difference between me and you. I have second-time learners. They've seen this before. They know that they can't get the right answer multiplying across. They know that they have that disadvantage. And your students hopefully shouldn't know that yet. Or if they do know that, it's early enough that we can correct it, is my plan. I don't know if it's possible. But I think it's something that's